Okay, so we are going to pick up from the other video. My mom called and she wanted to explain. I had an event on Friday, so she watched it, so she needed to tell me about that. But anyhow, we're back. Coach Payne's Learning Network. Okay, so the red-tailed hawk. I wanted to show you a red shoulder hawk. I'll do that next time if I remember. But okay, so let's get into, the whole thing about we just don't know, we just don't want to just do the math. We want to be able to know where it comes from. Why do we do it? But, I saw this key fact, so I just kind of wanted to go through this quickly. That, this word algebra here is derived from an Arabic. And this is interesting because my name is Arabic, Naima, but Al-Jabbar, right? Uh, the word is part of a title of a 19th century work. I mispronounced this, so I apologize. Hizab al-Jabbar, and then I'll let you give this a try. So, Wa Mu Qabala, written by Muhammad ibn Musa al-Khwarizmi. That was a lot, so if I butchered it, I apologize, dear sir. But anyhow, the word algebra, look at this, means restoration, restoring. What are we trying to restore to? So, and a reference to the fact is that a number is added to one side of an equation, then it must be added to the other side in order to restore the quality. The title of the work freely translates is The Science of Reduction and Cancellation. Of course, today, algebra has come to mean a great deal more. So this is just kind of a little information about it. So I just wanted to share that with you. I thought that was interesting. But this whole idea about algebra, right? So, we use mathematics to model, right? It's a modeling process. And so we have to take a real problem in words, break it up in a verbal description, and then translate that into the language of mathematics. So in all of this algebra, right, you're learning this language of how we translate real problems into a verbal description that translates into that math problem. And then we get some ultimate solution. And this is a process, right? And so a lot of times, we forget quickly the procedural steps. So you're going to be responsible of both explaining concepts as well as performing procedures. So in one of the videos, there was a big thing about the difference between an expression and an equation. So when you explain something, right, you're going to have to add your 2 cents in. So it was interesting, right? An expression is a math phrase, right? So it's a math phrase. Well, there's two of them. There is what you have the numerical and the variable expressions, right? So I gave you something on that pre quiz. I don't remember what it was, but it was something, I don't know, like this. This is a numerical expression. And when you perform the orders of operations, guess what? You get a number. Here you have, let's just say, I'm making this up. This is a variable expression. We do the same thing as we simplify. However, depending on what type of expression will dictate what rule you would need to simplify. And in this particular case, we would use combining like terms. Well, and that is simplifying this math phrase that doesn't contain an equal sign. So a lot of times people say, oh, expressions are, they don't contain an equal sign. That is incomplete, right? An expression is a mathematical phrase, right, that could contain what? A numerical components to them or variable components to them, and we simplify them. So on the other side, we have what we call equations. And there are a whole lot of equations out there, yeah? However, how is it said? It's a math sentence that has an equal sign. So here you have x squared, I don't know, I'm making this up, 5x plus 4 equals 0. So this is an equation, and algebra means to restore, to retain what? Equality. And you have some variable that has an answer. And what we do with these equations, we solve them. All right, we're looking for the value or the values that when you replace here, you're going to get the two sides to equal. And that's kind of what we did in our prereq course, pre-algebra, elementary algebra, intermediate algebra. Now we're in college algebra, okay? And so in the video of here, did you know that numbers have actual names to them? It's just not a number. What kind of number is it? So in that video, you illustrated the different types of numbers. And different textbooks use different language. So look at this. The union. Union means what? You're joining sets together. So you're joining what sets? The rational numbers and the irrational numbers. However, rational numbers also include integers, whole numbers, natural numbers. Are you able to tell me the difference? What the set of whole numbers is different from the natural numbers? Did we get that from the video? So when you're going through these videos, you've got to make sure that you're paying attention to detail, okay? So let's take a look here. So note, you will be expected to explain concepts using words. There's been a problem, so I'm just making you all aware that copying and pasting from the internet, from other sources, is not your explanation, right? So I just want us to clarify that and get that on the table. So how would you explain the following using words? A times 0 equals 0. What does that mean to you? Think about it. Think about it. Okay, well, this is what the text said. The result of multiplying by 0 is 0. Okay. So again, what would you say? Well, this is what I say, right? So if you take any real number, oh, what were the real numbers? Let's go back. Any of these real numbers that you talked about in the video, so it could be anything, and you multiply it to 0, your result is going to get 0. And I'm not saying that you have to be word for word from what I'm saying, but you do need to be able to explain it so I understand what you're saying. Oh, I think that's a hawk right there. Another red-tailed hawk. I get a lot of hawks in the area, so that's kind of cool. All right, your turn. Let's roll the dice. So choose the correct name for the set of numbers. 0, 1, 2, 3. What are these? Counting numbers or natural numbers? Whole numbers, integers, or irrational numbers? What do you say? And this is a quick question. Either you know it or you don't. So that's why on that drill, I only gave you 10 minutes. And so therefore, we should know that these are whole numbers and we move it on. Now, if you don't understand that, that's why we have a video that we could watch to get that. And you don't want to get overwhelmed. We can do this, but it's going to take a lot of attention, right? Practice puts brains in your muscles. So, if you're only doing, a minute a day, are you going to gain, the muscle that you want in order for you to grow in this course? Now, I don't want to spend too much time here, but I just want to go over. Express the statement as an equation involving the indicated variables. Again, prereq stuff. The area of a triangle is 1/2 the product, that multiplying, the is equals of its base and its height. So these are quick. We need to know that the area is 1/2 base times height. Done. All right. Another question. You are expected to perform procedural steps. Again, copying and pasting is not your work. We had problems last semester, so I'm just letting you know we're all aware. So what you're trying to track in those seconds, what is your process? What is this called? What am I doing? This is a product. So this is a product of two binomials, which is a expression or equation. Expression, right? A math phrase. What do? Well, you multiply. How do you do it? Well, and how do we do it correctly? So math, we do equals. So you distribute, distribute, distribute. And wouldn't that be a 2x cubed minus 2x squared plus 4x? Distribute, 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 plus 5x squared minus 5x plus 10. And then combine like terms. So that's 2x cubed plus 3x squared minus x plus 10. And box and done. And keep track of the time. Which ones are longer, which ones are not as long, right? Again, we're not going to get this because I want to keep this video short, but do you remember how to divide, right? What would be your process? You got to think about that. Right? This is our prereq stuff, and it's okay if we don't remember, but we need to recall so that we could brush up on that. That's why it's so important. Practice puts brains in your muscles, right? And so here, what do we do in this one? What does it mean to factor completely, right? Quick. So this would be a 2x here, this would be an x here. I would do a plus 3, plus 1, boom. And you could verify it, right? Make sure you get the 5x middle term. What do we do here, right? This is coming from the review. I'm not going to get into this because I want to talk about, but you can always pause. And these are the kind of questions that if we have them, let's do it now. So in your class, your course calendar, I just want you to know, we're talking about orientation this week. Chapter 1, Chapter 2 is review. We don't spend a lot of time. That's what this individual activity is for. And then your textbook, I'm just outlining, that it does go over key terms. You do have practice problems, but these ones here are not collected. And then your textbook is here. Your textbook, you could put the page number here. And if you're here, it gives you kind of more of a grid format. And yes, your textbook does have the answers. It's a little bit below here. And then just to show you, these are terms that we talked about in previous courses. It's a lot, I know. Then it goes over the key concepts and it tells you exactly where it is. You have review for each chapter and you have a chapter test. So we were kind of taking, what is this called? A numerical expression that we simplify, right? And so again, it does have the answers at the back. And then each section has some verbal that you want to start practicing with that. again, we just got to keep practicing. All right, hope this was helpful.